First definition, what is a rational function? It's when you have a function with x in your numerator and denominator. And characteristic number one, non-permissible values. And we know that non-permissible values will either be vertical asymptotes or holes, also known as points of discontinuity. Points. Points. Points of discontinuity. Now, we always talk about holes. We always write holes because it's shorter to write. There was an exam one year where they used the word point of discontinuity in the question. Everybody was like, what's that? So in case that happens, it's the same thing as a hole. So in this case, in this function, you have two non-permissible values, 3 and -1. Will those be vertical asymptotes or will they be holes? They'll be vertical asymptotes because they don't go away. So they'll both be vertical asymptotes. There's your graph. However, in this case, where we have an x minus 3 and x minus 3, we still have a non-permissible value. But in this case, those factors will simplify. And that equation can simply be written as x plus 1. You still have a non-permissible value that x can't equal 3, and so that 3 becomes a hole. To find the coordinates of that hole, you plug in 3 into the simplified equation. If I plug 3 into x plus 1, what's my y value? 4. And that's the coordinate of my hole. So we find the coordinates of our hole by plugging in the non-permissible value into the simplified equation. We can't plug the non-permissible value into the original equation because then we would divide by 0. But once it's been simplified, then you can plug it in. And that's when you get a hole. So we've got two different equations. Yeah, if you have this one, this x minus 3 would cancel out with one of those x minus 3's. So you would have a hole at x minus 3, at x equals 3. But since you still have another x minus 3 on the bottom, you would have an asymptote there because it doesn't completely simplify away. All right, example number 1. What we're going to do with all of our examples, in which case it makes section 2.3 and 2.4 the same. In 2.3, the questions just ask about characteristics and not about graphing. But in the end, you're going to have to graph everything. So we take the standpoint in 2.3. We're going to learn how to graph things all the way through just so you get lots and lots of experience with graphing. And we'll talk about the characteristics as we go. Use the equation of each function to predict whether the graph has vertical asymptotes or holes. Okay? And as far as graphing goes, okay, the steps for graphing is number 1, you're going to factor as much as you can and find all vertical asymptotes and or holes. It's going to be the first thing that we're going to do. So first thing, vertical asymptotes and holes. You're going to find that by factoring. Second thing for graphing, we're going to find all horizontal and oblique asymptotes. Three. We'll find all x-intercepts and y-intercepts. And I'll explain what I mean by one per section later on. So we're going to need to add some points. So step 1 and 2 are about drawing your asymptotes. Step 3 is about points. And then once you've done that, you'll have enough information to draw the graph. Which you can show the asymptotic behavior. And we'll talk about what that means. So, there's our steps. Here we go, just wait for it. Is that? I should get it right? Okay. Perfect. All right. Oh, yeah. All right. Zoom back to our page width. Okay, so what are we going to do for this equation? I mean, the question is just asking about vertical asymptotes or holes. We're going to graph it completely and follow these steps, so you get used to that. Well, it's really asking just about step 1. So step 1, you would factor completely to begin with, which gives us x plus 5, x minus 5 over x plus 5. Does the non-permissible value, right, our non-permissible value, x can't equal negative 5, but what happens to our non-permissible value? It simplifies. So we have a hole. And that hole, the x-coordinate will be at negative 5. We find the y-coordinate by plugging it in, and we get negative 10. Okay? And now, we're going to graph the simplified equation, which happens to be y equals x minus 5, with the hole. So once your graph simplifies, that's the new thing that you graph. And the new thing that we have to graph, which is x minus 5, that's something you already know how to graph. So basically steps 2, 3, and 4 of the graphing won't apply because you know how to graph y equals x minus 5. That's a straight line. What do you know about that straight line? It has a hole, so we can oops, that doesn't look like a very good hole. There we go. Label that hole negative 5, negative 10. But if I was graphing x minus 5, I would know that there's a y-intercept at negative 5. I guess you are sort of still doing some of the graphing steps. What else do you know about this line? It has a slope of 1, so you could go over 1, up 1. Maybe you find your x-intercept by plugging in 0 for y. And you draw your graph putting arrowheads on the end of your straight line with the hole, and we've got an empty hole on that graph.
Mr. Chair, when you're like drawing a hole in the exam,
Yeah.
as long as it's like in the right spot.
It needs to be in the right spot. So usually you get a grid that's given to you, and then you, with your labeling, like I just sort of estimated where I thought -10 should be. All right, second one.
As long as it's just like a single point.
Yeah. I can factor the top, I can factor out a 2, which leaves me with 2x plus 1. But after factoring it, it doesn't cancel. So when we're talking about step 1 with our asymptotes, well, our non-permissible value, x can't equal 2. In this case, we have a vertical asymptote at x equals 2. So I'm going to start my graph right here. And of course, in this equation, they're assuming you don't know anything else yet except asymptotes. Well, we can also figure out more about this graph. Step 2 was figuring out if there were any horizontal asymptotes or oblique asymptotes. So let's look at the original equation. Is there going to be a horizontal asymptote? Yes. There's going to be a horizontal asymptote at y equals. This is one where the degrees are the same. So if you ignored everything else, you just have 4x over x. So we would have a horizontal asymptote at y equals 4. 1, 2, 3, 4. We can add that in with our red pen. Y equals 4. Step 3 is about points. Can you find your x-intercept? Can you find your y-intercept? Well, y-intercept is the easiest because you just plug in 0 for x. If I plug in 0 for x, what do I get? 2 over -2, 0, -1. So if I plug that in, I get 0, -1. My x-intercept is when you plug in 0 for y. Now, if I plug in 0 for y, and I'll just do that up here, 0 equals, and I'll use the factored form. How do I solve this equation? Well, can you see that if you multiply both sides by x minus 2, the x minus 2 would go away and you'd still have 0 on the other side? Because 0 times anything is 0. The key thing about a fraction equaling 0 is a fraction is only equal to 0 when the numerator is equal to 0. So I wouldn't even have to multiply both sides by x minus 2. You can just look at your numerator and say, what would make my numerator equal to 0? And since it's already factored, you probably can see that it has to be -1/2. So we're going to get our x-intercept at -0.5, 0. Now in step 3, when I wrote out the steps for graphing, whoops, that's not right. Here we go. In step 3, I wrote out find your x-intercepts and y-intercepts and any other points we need, 1 per section. Now I can explain what I meant by 1 per section. Your vertical asymptotes split your domain up into different sections. When you have one vertical asymptote, your graph gets split up into 2 sections. Can you see that I have points in the left-hand section, but I have no points in the right section? Does that make sense? So we need another point in the right-hand section, and the way that we'll get that point is just by using a table of values and plugging in something. So what's a point on the right-hand section? Well, I'm going to plug in x equals 3. What happens when I plug in x equals 3 into this equation? On the top, I'll get 14. On the bottom, I'll get 1. 14 divided by 1 is 14. So I get this point, looks like it'd be way up there, 3, 14. Can extend this asymptote further if I need to. Right? You could, if you wanted to, you can find more points. What happens if I plug in 4? I get 18 divided by 2?
9.
I will get 4, 9. But only one point in this section is going to be needed, because then we get to step 4, and step 4, we wrote draw the graph, and in brackets I wrote asymptotic behavior. So now you're going to find out what asymptotic behavior is. It means that your graph will go towards asymptotes. So by having these points in this section, I have enough information to say this is what my graph is going to do. And by having points in the other section, and you would just need one of these points to be able to say that this is what my graph is going to do in that section. So even though these questions just asked us to find holes in vertical asymptotes, we're going to go through all the steps each time because there is just a number of different weird examples that come up. So we want to see as many as we can. So here's our first two. One of them, it was just a straight line with a hole. The other one ends up with this graph with a horizontal and vertical asymptote. Questions for practice number 5. But we're going to go on right now and look at characteristic number 2.